the expert on finding and fixing wind noises and air leaks. How about opening up and telling me some of your secrets?
Well, no secrets, Harry. It just takes common sense and some detective work.
Huh? You sort of lost me with that detective business. What do you mean?
Just what I said, pal. You go to the scene of the action, look for clues, check them out, and arrest the troublemakers.
I think you've been reading too many mystery stories, but no kidding. What's the best way to handle wind noise jobs?
Well, before we get into that, you should know something about general causes of wind noise to help you sort out the possible sources. You see, turbulence in the airflow around the car body is a basic cause of wind noise. Generally speaking, turbulence noise can be caused by anything that disturbs smooth airflow. This can be the shape of the body, protruding parts, or loose parts. A fully streamlined body shape would be ideal, but cars are designed to carry people comfortably, so we get some turbulence noise which cannot be avoided. Fortunately, the level of noise from this source is acceptable to most people, provided the body is well sealed. Turbulence noise caused by some protruding parts is a different story because it can often be altered or eliminated. Common examples of this condition are doors with front edges set out from the body surface and moldings which extend into the air stream. Loose parts not only set up turbulence but also tend to vibrate or buzz. This kind of noise can be quite disturbing, but in most cases it's fairly easy to track down and correct. Another basic source of noise is body air leaks. In many cases, the sound results from air leaking out of the car body. You see, when the doors and windows are closed and cowl vents open, forward motion of the car pressurizes the car interior with ram air. Besides, airflow around the car body produces low pressure outside the door glass on both sides of the car, especially in the front pillar area. With low pressure on the outside, the effect of inside pressure buildup is even greater. That's why, in hardtop models at high speeds, the difference between inside and outside pressure tends to force the top edge of the door glass outward. If the glass loses contact with the weather strip, the air that leaks out can cause a disturbing noise. Now, in the opposite direction, noise can result from air leaking into the car. In this case, we usually find a place where the weather strip does not seal, a hole or a poor body sealing condition. Sometimes this kind of leak also admits an uncomfortable draft, along with dust and water.
Okay, so you can have turbulence noises on the outside and air leaks that sound off on the inside, but how do you tell which is which?
Well, that's where the detective work begins. Actually, it's the old story of looking for the obvious combined with a process of elimination.
Al, before you start noise detecting, you'd better tell Harry why the upper areas of the car are the most critical.
Hiya, Tech. A good point. It's simple, Harry. Noises at ear level are more disturbing, and this is the area where outside and inside pressures differ the most, mainly for these reasons. Most wind noise complaints are caused by leaks in the upper areas of the car sides, down to about a foot below the belt line or around the windshield. Leaks lower down can cause drafts, but they seldom cause wind noises. Now, you can begin your search for wind noise causes in the shop by looking for the obvious. Check the weather strip in the noisy area for being loose, out of place, torn, or distorted. In some cases, you can eliminate the noise by simply replacing a damaged weather strip, but make sure that the new strip is not exposed to similar damage. Inspect the front and rear faces of the door for gaps or holes that can let air enter or escape. Seal any of these openings you find because even a small hole can produce a whistling noise or a pop bottle tone. Solder lumps or other uneven spots on the door opening surface can prevent full weather strip contact. Any high spots should be smoothed down and low spots build up to provide an even surface for the weather strip.
Don't be misled by the reported noise location. The cause may actually be some distance away, so don't pass up anything that should be corrected just because it isn't near the noisy point. And be sure to remember, small holes can make large noises.
Thank you, Tech. Now, when you're satisfied with the general condition of the weather strip and door or body surfaces in the noise area, roll up all the windows and shut the fresh air inlet doors so you can close off the interior to run a body air leak test. The main idea here is to use the heater or air conditioner blower to build up pressure inside the car. This lets you check on the outside for air escaping around the door and window openings. Any leaks you find will help you locate holes or gaps which can cause wind noise. Set the controls to admit outside air at top blower speed. Start the engine to move any vacuum-operated air doors into position, and then switch the ignition to accessory position to keep the blower running with the engine off. Connect a charger at the battery, close the car doors, and check for air leaks.
What's the reason for the battery charger? Are you afraid the test will run the battery down?
Well, not exactly, but you want the blower to build up the highest possible pressure inside the car, so you keep line voltage up with a charger when the alternator isn't operating.
Well, that makes sense. Okay, how do you check for air leaks?
The easiest way is to move your hand slowly around the edges of the door, the vent wing, and all around the window. Mark any places where you feel air escaping so you can come back to them later on.
What's the story on those electronic leak detectors I've been hearing about?
Well, they do help on a pressure test by picking up a tone signal at leak points. But even with a detector, you still need inside air pressure to check for poor weather strip contact.
If you want another way to check for escaping air, you can use a short length of small diameter hose as a sound pickup.
Like a stethoscope, huh, Tech? Okay, Al, you run the pressure test and come up with a leak point. So, you shut everything down and, well, then what?
Well, if the air leak is limited to a small part of the weather strip area, you may be able to fix it by shimming the weather strip. Large leak areas are usually caused by poor alignment of the door or window. In either case, you can use carpenter's chalk, tracing powder, or paper strips to show up any areas where the weather strip does not make good contact. The methods for checking with these materials are simple. To make a chalk print, simply open the door and rub soft carpenter's chalk on the sealing surface of the weather strip all the way around. The chalk on the weather strip transfers to the body door opening when the door is closed. With a good coating of chalk applied, hold the latch in released position, slowly push the door closed, and then reopen it. If you slam the door, the weather strip can momentarily flatten and distort the chalk print. Gaps or light traces in the chalk print indicate poor weather strip contact and give you an idea of its extent and the correction needed. If the chalk test shows gaps at body joints around the door opening, it may be necessary to build up the low points to get a good seal. Usually, you can level these spots with plastic solder and cover the repaired area with paint. The chalk print also shows up high spots on the door opening seal contact surface. These may be lumps of solder mentioned earlier, especially at body seam overlaps. In any case, the raised spots must be smoothed down and repainted. Now, on hardtop models, I use the chalk test only on the door part of the weather strip because the roof rail weather strip is visible with the door closed. We'll talk about checking the roof rail section farther on. If chalking the weather strip isn't practical, you can use paper instead. Clamp a narrow strip of flexible paper between the weather strip and the door opening at the suspected location. If the paper pulls out easily at some point, you found a possible leak. Many good technicians prefer to use dusting or tracing powder to check for leak points. All you need is the powder and a syringe to blow it in around the door edges and other test areas. Blow the powder in at the edges of the doors all around on the outer side of the weather strip. Vent wings and roof rail weather strips are prime spots for powder checking because leaks show up well with this method. In any case, after using the syringe, check for traces of powder on the inner side of the weather strip or vent wing seal. The powder will pass through and pinpoint the place that does not seal properly.
Hold up for just a minute, Al. We're at the halfway point of this film, so if someone will kindly flip the record, Al will continue his story.
After you check for leaks with powder or chalk, be sure to clean up the test area so the customer won't be bothered by messed up clothes or upholstery.
Okay, Al, I'm beginning to see what you mean by looking for clues to track down air leaks. But how do you track down turbulence noise?
Once again, you start with the obvious. Be suspicious of a molding that is loose, raised, or out of place. You can either correct it right then or temporarily cover it with masking tape before you make further tests. Even if you fix obvious things like loose moldings or open body joints, trying to find the cause of turbulence noise in the shop is largely guesswork. However, since outside testing takes time, it's a good idea to correct the possible troublemakers in the shop. The best way to track down the source of wind or air leak noise is with a road test. Besides, road testing also lets you check any corrective work you've already done in the shop. The ideal testing route is an open, low-traffic area where you can drive the car at cruising speed and pull over for tests or adjustments. Be sure to take along sealing materials and masking tape so you can isolate noise sources and make corrections on the test run. The antenna should be down all the way, and all the windows and doors closed tightly. Also make sure the radio and any blowers are turned off. Set the heater or air conditioning controls on the off position and move the air inlet doors closed. Drive the car at the speed where the reported noise is most noticeable so you can get an idea of the kind of sound you're concerned with. Sometimes a change in wind direction will vary or stop the noise, so be sure to check the effect of driving into and away from the wind. If the noise seems to be somewhere outside the car, it's probably a turbulent sound. Locating the source may take some experimenting because the sound and its cause may be in different locations. It's basically a cut-and-try process. When the noise sounds off inside the car, it usually means that air is leaking into or out of the car body. In most cases, you can identify an air leak noise by opening the fresh air inlet doors so ram air can build up pressure in the car body. As air pressure inside the car body varies, a change in the noise sound indicates that the cause is an air leak, probably at some poor contact point on the weather strip or a leaky vent wing seal. As I mentioned earlier, most wind noise problems seem to be found in the upper section of the car body. In fact, experience shows that the vent wing area is more critical than others. So let's start there. You can usually pinpoint the noise source if you first isolate the outside surface of the weather strip in the vent area. You can block off the pillar area with walls of rope-type sealer between the weather strip and the door edge. With the door closed, seal the space between the windshield pillar and the door edge on the outside with masking tape. Also, tape the inside sealing surface of the vent wing all around and then test drive the car again. If the noise is gone, stop the car so you can pull the tape away from the pillar and then make another test run. If the noise returns, you'll know that the source is somewhere in the pillar weather strip area. If no wind noise is noticed when all the tape is removed from the pillar, repeat the same testing process but pull the tape away from the vent wing in sections. When you get to a place where the noise sounds off again, you're near its source.
Hey, how about using the same test to find weather strip leaks at other locations around the door?
You're catching on fast, Harry. Just make sure you isolate the outside of the weather strip with rope-type sealer section by section so you can tell where the sound is coming from.
Here's another place where you can use a length of small diameter hose as a noise pickup. Move the free end of the hose around the vent or other locations around the door and listen for the sound at the other end. That about wraps up air leaks, Al. How about turbulence noises?
Well, we've already talked about loose moldings and body joint gaps or openings. If everything appears shipshape, you can close off or cover other suspected areas with masking tape and make additional test runs to check the effect.
Sometimes you can locate a turbulence noise source by changing the shape of suspected parts with masking tape or rope-type sealer. If the wind noise changes after the alteration, you've found the cause. Al, I think Harry understands the wind noise detective work now. So how about a few pointers on things to look for?
Just what I had in mind, Tech. So let's go back to weather strips. Sometimes after a rainstorm, the dried road splash around the door opening surface helps you to spot leaks. If the weather strip lets in water, it can also let air in or out. And while you're looking, check the alignment of the door in the body opening and also note whether it is flush with the adjacent body surfaces. On hardtops and convertibles, you'll have to check both the door and the window alignment. Ideally, the gap all around the door should be uniform, with the forward door edge flush or slightly below the body surface. There's some leeway here, but serious misalignment can prevent good weather strip sealing.
And if the forward edge of the door sets out, it's open to the airstream and you can get a loud wind noise. This open edge can also act as a scoop for dirt and water. How about the rear edge, Al?
The rear edge of the door should also be nearly flush when the door is fully latched. If the latch striker adjustment is not correct, the door may not close properly. This can prevent good seal contact or may result in weather strip damage. You see, when a door is properly fitted, the weather strip compresses slightly as the door closes. This allows the strip to make firm, even contact all around the door opening so it can maintain a good seal without being flattened or crushed. On hardtop models, good weather strip sealing depends on proper alignment of both the door and the glass. The standards for door alignment and closing are the same as for sedan and two-door models. The top edge of the door glass must align with the roof rail weather strip to make a tight seal. You may have to realign the glass, but remember that any adjustment you make will also affect the fit of the front and rear ends. When fully raised, a properly adjusted door glass should raise the weather strip main lip so its shoulder line does not show. In this position, the glass should also touch the weather strip secondary edge. When you realign the top edge of a door glass, remember that the front edge of the glass or the vent wing frame should parallel the pillar weather strip retainer with equal separation top and bottom. For minor corrections in pillar weather strip contact, you can shim it out by cementing a strip of closed cell sponge seal tape between the weather strip and its retainer. If extra shimming is needed, insert the sponge tape between the pillar and the weather strip retainer.
You can open an air leak gap if you don't make sure that the retainer shim strip extends to the end of the retainer. Even without a shim, the existing foam seal strip must also be flush with the retainer end to seal properly.
Good points, Tech. Now, in some cars, a wind noise can result from a gap under the molded ends of the door weather strip. The best solution here is to install a strip of closed cell sponge seal tape between the weather strip and the door surface. When you check door and window sealing, make sure the end of the weather strip does not distort or pull away as the door closes. Cementing the weather strip end may be all that's needed. Incidentally, if you install a new weather strip, make sure it is correctly positioned by lining up the index notches in the weather strip with the locating tabs in the retainer. Also, check the vent wing weather strip for puckers or distortion, especially at the front lower corner. This type of distortion can be caused by the glass moving out too far due to regulator over travel. On some cars, you can reshape the weather strip by softening it with a heat gun. When the material is pliable, smooth out the pucker carefully and work it into shape as it cools. The pucker may need a couple of treatments before it stays put. In some cases, the lower end of the vent wing weather strip lifts up from its normal position and causes a leak. If the weather strip is otherwise in good condition, the lifted section can be cemented down. The bumper at the top of the vent wing frame can distort the roof rail weather strip if it is out of position. Usually, you can correct this problem by simply repositioning the bumper.
Okay, Al, that's about all we have time for now. Your detective story should give Harry and all of our master technicians plenty of clues to follow in tracking down the causes of wind noise. Along with all we've covered here, you'll find more of the same sprinkled through the reference book for this session. And always remember, when in doubt, check it out in your service manuals. So long till next meeting.